And the reason why we can't put a link in there and put everything on grid for now is because it has to go in and out of this thing. If this is off, if this inverter's off, it goes straight to grid. So that's what it's doing now with the battery off. But the reason is the output of the inverter is not in sync with the grid frequency. If you join the two together, kaboomage. So this is as good as it gets for isolation until the inspector approves it. You can't do anything more than turn the battery off. So as you can see, the backup circuits are still working even with that backup neutral out, because I know that this system, when it's off or failed or what have you, it will automatically connect the backup loads to the grid. However, before we were getting 120 volts when it was in UPS mode. So now let's have a look at that. So I've actually put the main switch here. As you see, the 6mm coming in, 32 amp breaker. Now the grid is off, so therefore this is off, because this meter is a grid connect meter for export control. That's why the active goes into the grid side. See how this comes out through the CT up through here and off to the inverter on the grid side, as well as the kilowatt hour meter. The neutral is thus put into the neutral on the grid side of the inverter as well, and the backup neutral comes from the inverter there into the same neutral bar now, immediately adjacent now for safety. Don't want it over here, because if someone removes the link, we've got a voltage to earth of only 120 volts. So now we're going to test it in backup mode. All of the loads should still be working at 240. There we go, as usual. However, this time we should also get 240 to earth, which we do. And the reason for that is we now have an MEN connection with this link in here. The neutrals are now connected to the earth by the MEN link. That was not there earlier because of, I wasn't here to test it, and there was no real documentation on it in the manual, and they differ from model to model. Okay, that lead is snagged on that side, and that one is probed into the earth. We've got another meter, probably a better meter for it. Hit go, it's on the ohm scale, and we're getting 0.15. As you can see, it's in UPS mode, so the switches are on, and that's the situation. So that test is also good, and I've got to say, I wasn't here to test it properly because this had a secret circuit breaker, which I've now labelled behind the cover here. Main battery isolator behind that cover, and there's the shutdown procedure, which is specifically for this one. Mentions the button here, which can cause confusion if you don't have that with a generic label. So that's that, and one more. Got a site map and all the rest of it. Okay, let's test these in UPS mode. 1, 2, 3, 4, 5. More dramas. It turns out that the screws in these were loose. Some of the circuits were coming on and off intermittently. So here's our ACR10 acral meter, as written there on the top left, if we can. There it is. And it says here in the text, CT should be pointing towards the energy system, away from the grid, which I confirmed earlier, which is now there. And here's this is the thing. There's no, well, the grid's off. I'm going to turn it on now. And if we let that fire up, you'll see very soon that there's nothing reading there. Now I've followed the instructions, and as you can see, there's a dot line going between neutral to 4 and active to number 1. Now I'd say that dot is meant to be connected. It hasn't really specified. As you can see, a little bit misleading, but we'll get there by connecting those two. Okay, now we have some grid voltage. What happens if I press the up and down button here? So we've got a little bit of current there as well, and all the readings are going well. One last test. I think I did this test earlier on the DC, some current setting, because I'm used to testing PV, caught myself out there. And something else, confirmation. So I'm pressing 0, there we go. And this is to make sure when the grid is off and we're in backup mode, for white wire, everything's on in the house, that there's nothing flowing through the earth from that multi-core which goes to the inverter. To confirm it, we should have current, all the current flowing through the neutral. There we go. And how much amps? I'm going to ask them to turn something on. Righto, now we have a load. So we've got the tonk tester on the neutral, on the AC scale, right, and we're getting 8.7 amps. Now we take that off, put it on the earth. Now, this is why I didn't have that link in there in the first place. It's because some inverters have an MEN in the earth, and we don't want current flowing through the earth. So as you can see, no current flowing through the earth. That's just zeroing out, I guess. Yep, no problem. There you go. Up here again, put it on there. So some models, see, 8.7 amps. So some models will have the MEN. Let's just put that stuff down there, go out in here and have a quick look. Some of them will have an MEN in here. This one doesn't. So if it has an MEN there, it would have got a fault current, parallel current through the earth, because it's joined to the neutral here and joined to the neutral there, and that's very bad, because if a neutral becomes disconnected, then the whole earthing system of the house gets livened up. That's a real dangerous one. That's why I kept the neutral bar separate, but we've confirmed that this one does not do that, and that was confirmed by the inspector, who found that because these inverters are tapped halfway down the 240 volt cycle, he got a neutral with 115 to earth, and also the active 115 to earth. Just a little bit of a rearrange here. I've got the inverter switch now next to the critical circuit UPS switch. So that's coming out of the main switch now to the left. So that goes through there, off to the inverter, back out here and off to all of these. Okay, there's a string there, and we've got 233 volts, correct weight. And the other one here, with only 4 panels on it, 155 volts positive, correct weight. I think the inspector left that off. It gave the impression that these strings weren't working. But let's do another test. That is to put it on the amp scale, DC, and now clamp it on there to see what sort of currents we're getting. Minus 1.8. If we flip it the other way, we'll get positive 1.8, 1.3, depending on how well this is calibrated. 1.5. These are short circuit currents. -2, so it's a little off center of the calibration. 0 that. There we go. 0. There we go. Now try it again. So we got 1.5 that way, and minus 1.5 ish the other way. That's all good. So that is a low current, but at least it shows the arrays are fine, and it's a low current because of the weather. Should be up around 8 amps when it's got full sunlight overhead, but that's not the situation right now. But that's confirmed that the array is working nice. Also, as you can see, PV1 is on the left, PV2 is on the right. I don't know if you can see it up the back there as well. There you go. So right is PV2. So as you can see, I've got a pair with the cable tie there, and the other pair with the other cable tie going into the left-hand side. So they're not mixed up either. Everything's good. No worries. So we've got battery nothing. Why? I turned it off here at the battery there. And the reason for that is we only want it to operate in grid mode at the moment until the inspector gives it the nod. It says battery management system lost fault there too. So it's operating like a grid connect inverter at the moment. So that's to prevent the UPS coming on until the inspector is satisfied with the floating voltage of the earth.